Okay, so to get these started, we're going to first start off with the sum formula, all right? So, and you will be missing some variables. So you're not going to be able to go straight and just plug in all the parameters and get an answer right away. You will have to figure out what the missing one is. I don't want a rectangle. So we're going to do the sum. All right, sum here will equal the number of terms, which we don't have. So our missing variable here, right? We don't have what these are, right? So we're missing this, and these are the same number. This over here on the left just says how many terms you're adding up. You don't actually do any calculations with it. That just stays over there, right? And then we have this. And then we're going to multiply that by the sum of the first term and the last term, right? So our first term is 3. And our last term is 99. Okay. But I can't complete this because I don't know how many terms there are. But we could go and find out what the difference is, right? And then plug it into this formula. So I'm going to do that. I'm going to do from 11 minus 3 is 8. 19 minus 11 is also 8. So I confirm it's an arithmetic series. So I'm going to use this formula, and I could find out what n is. So I'm not going to know what n is, but I could fill out what these are, right? All three of these, and then work backwards and solve for n. Get that n, plug it back into here, and then I get the sum. And that'll be the process for all these problems. Start here, go to this formula, get some answer, and then come back to where you started and complete the problem. You might have n missing, you might have the first term or the last term missing, something will be missing. So it'll be the same but slightly different for each problem. So we got, first of all, I can write this out like so. All right, plug in all my values. So my last term is 99. My first term is 3. And got my difference, which is 8. And I'm solving for n right here. So just do a little mathing. Subtract 3 on both sides. We'll get the 96. I know a lot of people at this point would probably distribute the 8, but I can see that 8 goes to 96 evenly, so it might be a little bit easier just to divide both sides by 8. If 8 didn't go in this number evenly, I would probably distribute, right, get some fraction. And then I can add 1 to both sides. So turns out there are 13 terms, which means I have to add 8 13 times to start at 3 to get to 99. That's what this answer means. And now I can finally go back to got my answer here. I can finally go back to where I started here and say, now I know it's 13. Adding up 13, the sum of 13 terms. All right, and now I can complete and actually find the sum, which is our original question. So we have these little answers throughout, but not the actual answer to the question. So we have, let's see here, 3 plus 99 is 102. 102 divided by 51, so 13 times 51, which is 500 plus 113, so 663. There we go. All right, so give this a try for the next problem. Let's go ahead and find the sum of 50 terms. So this time it gives you n, right? On this first problem, it didn't tell us it was 13. We had to figure that out. But this one, it does tell us. But it doesn't give us the last term. So they're the same but different. So when you're doing the problem, you'll plug in everything except for the last term. And then over here, instead of solving for n, you'll be actually solving for the left-hand side, the last term. Get that answer, plug it back in. Give that a shot. So take a look at the color coding I'm using. It might help out because there's a lot of things floating around, 4 different parameters we're using. So notice how they're repeated in both formulas. So 98. I'll just do 5 times 200. And once you get there, just try A. It's very similar. Looks like we're finding the first 10 terms. Now, when you get to the radicals, you might look at that and say, I'm not sure what to add to root 3 to get 3 root 3. So you could do the algorithm and actually subtract the second minus the first one. So you could do 3 root 3 minus root 3, right? And that'll give the difference. If you're still kind of rusty on your radical or square root arithmetic, just remember this is the same as if I instead had an x instead of root 3, it's the same question as this. So what is 3x minus x? Right? That's just 2x. So 3 root 3 minus root 3 is just 2 root 3. Right? So our difference here is just 2 root 3. But this problem is neither more easy or more difficult, so don't change things up just because, it has radicals or has fractions or something like that. It's the same steps. I'll let you keep going on that. See what you get. 15. Lastly, we have some problems dealing with arithmetic means, which just means are the in-between, really. So if we look at these, of this sequence right here, we have 5. So there are 3 numbers in between the first and the last, and those are called the arithmetic means. Right? So what's going to happen is you're going to be given the first and the last, right? So if I'm being consistent, that's going to be the first, right? That's going to be the last, and then you're finding, right, the numbers that go in between, and it'll tell you how many, because that'll affect what the difference is, right? So it has to tell you, in this case, 3, right? If it was 4 or 5, you'd have different numbers, right? So here we go. So another way of looking at it is that we're going to have the first term, and then we're going to have 3 numbers in between that have the same difference, right, to get to each one, and at the very end we'll have the last. Where I got 3 from, but let's make that a 9. Oh, that's why, because I was looking out there. There we go. That's a 9. So you might be able to figure out, well, what do you add to 9 to get to here, to get to here, to get to here, to make sure you get 33? You could do a lot of trial and error, but not too much trial and error, and you could figure it out. But you can imagine if we use a lot of big numbers, or the difference was like decimals, it would be a little more difficult. So if we have n, right, that's what this is. We have how many terms, right, total, which is not 3, but we have the 3 we're trying to find, but we also have the first and last. So total, we have n equals 5. So we have n equals 5, and we have our a1, our first term is going to be 9, and our last term is going to be 33. And we could do the same thing we did up here on this left column, use this formula to find some value that we're missing. In this case, we're looking for D, right? We're looking for the pink number, and that way, once I have that number, I can just add it to here, get this number, add it again, get this number, add it again, and get this number. And that's how I can find my missing numbers. And so we'll have 33 equals the first number, 9er, plus n minus 1, in this case n is 5, and the distance is what I'm looking for. So we'll have 24 equals 4 times d, and that makes d equal to 6. And we probably could have figured that out with some trial and error. You know, we could probably try 4. We know 5 wouldn't, probably work, and then 6 might be our second guess. But we're just using some easy numbers for now. So we got plus 6. 9 plus 6 gives us the first arithmetic mean. Add another 6, we'll get the second one. And add a third one, get 27. And also do the last one as well. Even though we have our answer now, right? This is going to be what the arithmetic means are. But let's just say you picked the wrong value, right? Let's say you picked the wrong value and you just added it. You want to check it one more time, because if this plus this doesn't give you the last term, that means your d value was incorrect. So always do it all the way through, and if it doesn't actually work, try again, find a different value of d. All right, so, and let you try that last one, and you have your assignment. Give that a go, see how it works for you. 18 plus 4 numbers. So -2 equals plus ta-da.